Today on Sci Guys, gravity water drop. Don't break eye contact.
Welcome to Sci Guys. I'm Ryan.
And I'm Mark, and on today's episode, we'll be doing a gravity water drop.
Thank you, Gravity, for keeping us grounded.
What did we say about puns?
5 minutes in pun prison.
Sorry about that. Gravity is a force exerted by all objects with mass that causes them to be attracted to each other.
The equipment we're going to need for this experiment includes a disposable cup,
A pen.
water, and a container or sink to catch your cup in.
Although we're not dealing with anything dangerous in this experiment, we always recommend using safety goggles and a lab coat or apron to protect from spills and splashes.
The first step in our experiment is to poke a hole in the side of your cup near the bottom.
For the next step, simply take the cup, cover the hole we made with your finger, and fill the cup with water. For the first test in our experiment, hold the cup over a container and remove your finger from the hole.
When your finger has been removed from the hole, you'll notice that water will begin to pour out of the hole into your container. The second test of our experiment is to hold your cup of water over a container with your finger covering the hole and drop it. The cup fell really quickly. Let's watch that again, but this time in slow motion. If you watch very carefully, you'll notice that the water in the cup doesn't pour out of the hole as it falls. Let's look at this experiment a little closer. Gravity is the phenomena by which all things with mass are brought toward each other. Without gravity, we wouldn't be standing on the ground, but instead floating into space. Gravity is most accurately described as a consequence of the curvature of space-time caused by uneven distribution of mass and energy. But that's a pretty difficult and confusing description. So for the purposes of this experiment, we will be using a description from Newton's law of universal gravitation, which describes gravity as a force where two objects with mass are drawn or attracted to one another, where the amount of attractive force is proportional to the mass of the object. Gravity between two objects decreases the further away the objects are from one another. Now that we have that over with, we can look at our experiment. In the first trial of our experiment, we hold the cup in our hand, and when we remove our finger from covering the hole, the water pours out the hole. This is because gravity wants to pull the cup and its water toward the earth. Our hand is strong enough to resist gravity's pull on the cup, but since there's a hole in the cup and nothing holding the water, gravity will pull the water through the hole in the cup because it's the easiest path to the ground, accelerating it downwards toward the earth. In the second trial of our experiment, we dropped the cup at the same time as removing our finger from the hole. But as you saw earlier, the water didn't pour out of the hole while the cup fell to the ground. Why is that? When we drop the cup, gravity pulls on both the cup and the water at the same time, accelerating both of them towards the ground at the same rate, and causing them to land on the ground at the same time. Because they fall at the same rate, the water is already taking the easiest path to the ground, and it doesn't get a chance to pour out of the hole.
Well, that's it for gravity water drop. Thanks for watching.
If you